Welcome again. Today we are talking about principle of superposition under electric forces and fields. Now, when we are talking about electric forces and superposition, when we were doing Coulomb's law, we were dealing with two charges. Now, what about if there are more than two charges? That's where principle of superposition comes in. So that's where, and this is where most students usually find difficulty. So we never calculate one big force at once. In superposition, we calculate the force of each charge, then at the end we add the two forces. But before we go further, what is this superposition? What is this principle of superposition? So superposition states that the net charge on a charge is the vector sum of the individual force exerted on it by all other charges. So this one just states that the net charge is the summation of the individual forces that are acting on it. So for example, given this setup, for us to find the net force, we need to find the summation of the forces that are acting on what? On charge, this one, charge 2. Now, how do we find the net force, like for this one, for this setup? So we use this formula, the same formula for Coulomb's law, which is force is equal to K Q2 Q1 over R squared. But for this one, first we are going to find the force on Q2 due to what? Due to charge 1. And how do we find this? We say force 1 is equal to Q2 Q1 over the distance that is separating. So this is for force on 2 due to charge 1. Now the most important thing here is the direction. Both charge 1 and charge 2 are positively charged. So what's going to happen to charge Q2? So charge Q1 will act on charge Q2. At the end, since they are repelling, Q2 will go to the right side. Since Q2 is going to the right side, the answer of this one will be what? Will be positive. So F21 will be what? It will be positive. Again, we go to the force that is acting on charge 2 due to what? Due to Q3, which is charge 3. So since charge 3, when it acts to the left, which acting on charge 2, what's going to happen to charge 2? Charge 2 will go to the left since they are repelling. So force 3 is equal to KQ2 Q3 over R squared. But for this one, the answer is what? The answer is negative, since it's going to the what? To the left. Now what's going to be our net force? Our net force, when we add these two, we are going to have force 1 minus force 3. So that's going to be our net force. So you have seen the definition of superposition being described by these calculations. You are seeing that we are finding the what? The individual forces first. For example, F23 is an individual force and F21 is an individual force. Then at the end, we add them. That's what it meant when they said summation. Now let's talk about the rules of superposition. So for superposition, the rules which are there are, the first one is calculate forces one at a time. Second, each force has a direction, say the right or left. Forces are vectors, not just members. The fourth one is add forces using direction, signs or vectors. And never combine charges first, combine forces, not what? Not charges. So having talked of that, let's try to do an example on superposition. So here is an example. three charges lie on a straight line. We have charge 1, which is 2 microcoulomb, and charge 2, charge 3. And the distance between 1 and 2 is 0.23. The distance between 2 and 3 is what? Is 0.2. Oh, here I made a mistake, not 0.23, it's just 0.2 also. So now we want to find the what? The net force on Q2. So we are going to illustrate this one. We have charge Q1 here, charge 2, charge 3. The distance here is 0.2, 0.2. So when you look at this, charge Q1 and Q2 have the same magnitude, which is 2 microcoulomb, and charge 2 is what? Has 4 microcoulomb. Now, how do we find the net force? Just as I said earlier, we just follow that step, nothing difficult. So we start with F21, which is charge force on charge 2 due to charge 1. So we go. So what's our K? We use the same formula, K Q2 Q1 over R squared. So we use the same formula. So force 21 is equal to, what's K? K is 9 times 10 power 9. So times, what's our charge 2? Charge 2 is 4 microcoulomb times 10 power negative 6 times what about 1, which is 2 times 10 power negative 6, of what's the distance that is separating these two, which is 0.2 squared. Try punching on your calculator, and the answer you are going to find is 1.8 newtons. Is it to the right or to the left? To the right. So for example, we have Q1, Q2, Q3. So Q1 is acting on Q2. What's going to happen to Q2? Since they are all positive charge, Q2 will go to the what? To the right. Since it's to the right, it's going to be positive. So for force 21, it's what? It's positive. Let's go. So keep this value, which is 1.8 newtons, to the right, which is positive. Keep this value. Let's calculate also for force 2, 3. So for force 2, 3, same situation also, which is K is 9 times 10. K is a constant, 10 power 9 times, what is 2? 4 times 10 power negative 6 times 2 times 10 power negative 6 over 0.2. If you look at this, you are going to see that they are just similar. The magnitude is the same, the distance is the same. So the answer is still 1.8 newtons. But what about the direction? The direction, Q1, we have Q1, Q2, Q3. The direction, Q3 acting on Q2. Q2 will go to the left. They are all positive charge. So it's negative. So have you seen that the value we found earlier was 1.8 newtons also? Now how do we find the net force? So for net force, we just add the forces that we found. What's the forces that we found? It's 1.8 newtons and what? And negative 8.1 newton, negative 1.8 newtons. So the F net is equal to 1.8 minus 1.8. So the answer is 0 newtons. So that's the answer. That's a net force. So what we can conclude here is that two charges having the same magnitude and same direction, but opposite direction, will always result in what? In 0 net force. What happens if charges are not in a straight line? So if charges are not in a straight line, we resolve forces into x and y components, then add them. So if they are not in a straight line, we do something like vectors. We resolve them into x and y components. Then after that, we know how to add vectors. If you find x component and y component, then you find the magnitude. That magnitude is your what? Is your net force. Now the common mistake that students make is, the first one is adding charges instead of forces. Another thing is ignoring direction. Direction matters in superposition. Even when they ask in exams, they are going to trick students mostly in terms of direction. Another mistake is using wrong distance, forgetting that force is a vector, mixing signs with charge values. So in superposition, direction is more important than what? Than numbers. Now, the exam tip that I'm going to give you when you are dealing with superposition is, the first step is calculate. What are you calculating? The force. Next step is direction. Look at the direction, whether it's on the straight line or not on a straight line. Then the last one is add the forces. That's the summary I can give you on what? On superposition. So superposition means forces act independently. Let me give you a summary on what we have talked about. So this is the summary. Forces act independently. Calculate each force using Coulomb's law. Add them using direction. The result is the net force. So thank you for watching, and don't forget to subscribe.